Let's implement the in-order traversal function. So here in this example, we have 10 at the root, then 5 is inserted, goes left, 15 goes to the right, 20 goes to the right of 15, 7 right of 5, 3 left of 5. So if we apply in-order traversal, what you want to get is begin with the root, don't do the displaying the value yet. In order means a left subtree and then node and then right subtree. That's the order. So take care of left subtree first. And left subtree, as you go down, don't display 5 yet. Go to the left subtree first, 3. And then in order 5, go to the right 7. Now left subtree is done. Time for 10. Go to the right. Don't do 15 yet until left is done. Left is nothing. So 15 and right of 15. So that's what we expect from in order traversal. So as we implement the function, and then if I call in order, then the value should be displayed in that order. So let's give the public interface no return value in order function. However, we are going to implement that as a recursive function. So recursive function, we need to give a root node so that we can call recursively. So let's define another in-order function with the function overloading different parameter. So here root node is provided. On the root node we keep recursively call and accomplish in-order traversal. So let's implement those functions in public interface void class name in order. We want to simply call in order private implementation by providing the root node of that. So in private implementation, binary search tree in order, root node is provided. So let's apply recursive function implementation. Step 1, solve for a trivial size. Trivial size would be if a tree is empty, then we do nothing. So it's a very trivial case. Step 2, assume any smaller size solution is available. So we know how to solve any smaller size. Step 3 is solve for current size using the assumption. Assumption means a solution for any smaller size problem we have and then any known facts. So combine those things. Let's just solve it. So in order traversal, what's the meaning of the assumption in step 2? Assume we know how to do so in any smaller size. That is interpreted as follows. So we have a tree root and left subtree and right subtree. Then step 2 means any smaller size. So for left subtree, we know how to do in-order processing, in-order traversal. That's the meaning of that. So assumption on the right subtree is smaller than entire tree. So we know how to do so on the right subtree. How to do so means how to do in-order traversal. So then how do we solve? In step 3, how do we solve for entire tree? Is that since we know how to do so left subtree, step 1, do in-order traversal of a left subtree. Then print the value at the root. Then do in-order traversal on the right subtree. Just to do in 3 steps, then we solve for the entire size. So let's write the program for that. So here in private implementation, we just apply the recursive function design principles. If trivial size root pointer is null, it is empty. So all done, do nothing, so solved. Otherwise, do in-order traversal for the left subtree, in-order traversal for left subtree. Then print the value at the root node. Then do in-order traversal for right subtree. So solution itself is very simple. Trivial case solution. Assumption is we know how to do smaller size, then solving for the entire size is do left subtree, then do at the node, and then do right subtree. It's a very simple solution. So here, let's try that, compile the program, and then let's run it. What you get is 3, 5, 7, 10, 15, 20. So that's what we expected. So in order traversal function is implemented.